Hi, in this video, I'm going to introduce the basics of IPv6 subnetting. If you'd like more information on IPv6, including IPv6 subnetting, I hope you'll consider my book, IPv6 Fundamentals, 2nd edition, or the live lessons, both by Cisco Press. Okay, subnetting in IPv6. Can you count in hex? Then you can subnet. Okay, because in IPv6, it's really that easy. We have a 16-bit subnet ID in IPv6. Where does that come from? Okay, we're allocated what's known as a global routing prefix. In this case, it's a /48, which is common, but not always the case. Then most of our networks, and highly recommended all of our networks, unless some rare occasions, are going to be allocated, our subnets are all going to be /64s, even our point-to-point links. Okay, that gives us, in this case, between our global routing prefix, this is how our provider sees us as the first 48 bits. Between that and the /64 is our subnet ID, in this case, 16 bits. So all I have to do is count from 4 hexadecimal zeros to up to 4 Fs in this case, count in hex, increment by 1. It's that easy. So I can actually have 65,536 subnets, each one with 18 quintillion hosts. Okay, we can abbreviate these. It shows the abbreviation for the hex for the address. Okay, but it's that easy. We don't have to worry about conserving address space like we do in IPv4. Okay, and subnetting is not an afterthought like it is in IPv4. Subnetting was planned into the IPv6 address. Okay. Now, I mentioned that you always want to use /64s. That helps support /64 addresses. That leaves 64-bit interface IDs. Can you subnet into the interface? You can if you want, but if you do, I would suggest subnetting on what we call a nibble boundary every 4 bits. It just makes your life easier. That way, all you have to do is count in hex. So like going from a /64 to a /68. But then again, you really don't need to do this, okay? Under rare occasions, will you ever want to borrow bits or use bits from past the /64 into the common 64-bit interface ID? You want to push into there unless you got a special case. And I talk about some of that in the book and also in the video, okay? But subnetting on a nibble boundary makes it easy, okay? Because you just have to count in hex, okay? So every 4 bits, you increase your mask if you want to do it that way. All right, can you subnet within a nibble? You can, okay? If I wanted to go to a /70, let's see what that would look like. The problem with /70, well, not a problem, is that 2 of the bits are allocated for the network portion and 2 bits for the host portion. So although there's a pattern to the counting in hex, it's not as simple as it's incrementing in hex. Stay away from this. Again, pretty much stay away from anything other than a /64. Just use your subnet ID between the global routing prefix and the 64-bit interface ID and just increment that. It's that easy, okay? So remember, in IPv4, we have to borrow bits from the host portion to create our subnet. In IPv6, okay, we have our global routing prefix that's allocated to us by our provider. That's how they see us. The space between that, in this case, the /48, and the /64, which is what we want to use for our subnets, that will be our subnet ID. Makes life much, much, much easier. Okay, all we have to do is increment count in hex. There we go. Remember that VLSM scheme that we had in IPv4? In IPv6, it's really easy. because we don't have to worry about VLSM. Okay, we don't have to worry about conserving IPv4 addresses. We don't have to do that in IPv6. We give everything a /64. Okay, which means that each one of these networks, all of our buildings and these links, can have up to 18 quintillion devices. It's a lot. But again, this isn't about needing that many devices. It's about making it easy to do our network management, our address schema, our address plan, and put our resources where they're needed. We don't have to spend time trying to figure out VLSM addressing schemes when we can spend time analyzing our network, looking at traffic flows, looking at security, looking at performance, meeting the needs of our users, meeting the needs of our business. Okay, so that's what 18 quintillion looks like. Okay, so we have 65 with the 16-bit subnet ID gives us 65,536 subnets, each one with 18 quintillion devices. Okay, so there's a nice little Perl script you can use. If you can get it from GitHub, you can get it from GitHub. Make a really nice IPv6 prefix generator. Shows you an example from my Mac here. I'm using it. This just shows us it's called IPv6 gen, and I'm taking this /48, and I say, give me 64-bit subnets, and it generates all the 64-bit subnets, all 65,536 of them. Okay, here's an example. What if I took a /48 and I only wanted to make them /52s? Okay, there's my 16 subnets. Okay. All right, nice little tool there. I might also want to recommend a friend of mine, Tom Coffing, his book. If you're at a place where you're moving towards IPv6, which hopefully you are, how to do IPv6 address planning. Some really nice advice and templates and other things there. All right. Okay, hope this helped you understand a little bit more about IPv6 subnetting and why it's so much better than IPv4.